Hi all, this is Dr. Princess Maria John, Assistant Professor, Department of Computer Application, Hindustan College of Engineering and Technology. I am going to present a small video regarding the deployment models in cloud computing. In this video, we are going to see the need for cloud computing, cloud deployment models, principles of cloud computing, and NIST reference model. There are many purposes why we go for cloud computing. So to start with, the first one is highly scalable, which means that we can scale up or down our operation and storage as quickly to suit our situation, like allowing flexibility as required, like rather than purchasing on or provisioning the expensive upgrades. We have cloud service providers who can handle all this. Using the cloud will help us to free up our time so you can get on with running a business. The second point is flexible. Cloud offers businesses more flexible overall when considered with hosting on local servers. If we need some extra bandwidth than a cloud-based service, it can be met it can be met instantly, like rather than undergoing a complex or expensive update to our IT infrastructure. Next comes reduced infrastructure cost. See, moving to cloud reduces the cost of managing and maintaining our IT systems. Like rather than purchasing expensive assets and equipments for the business, you can reduce the cost by using the resources of cloud service provider. It also helps to enable our operation and managing cost because the cost of the system upgrades, new hardware, software may be included in our contract. There is no need to pay wages for expert staff. The energy consumption cost may be reduced and fewer time delays will be there. Next need is like highly secured. Like for many cloud customers, security is a priority. Like users will buy more than a traditional environment based on their reputation for integrity, confidentiality, and resilience, which remains a strong incentive to enhance security, but practices and compete in security for cloud providers. And cloud computing is highly available. Highly availability refers to a system which includes network, server or cluster, etc. anything that is designed to avoid loss of services by reducing or managing failures and minimizing planned downloads. Say for example, in an organization, the system is expected to be highly available when life, health and well-being, including economic well-being, are at stake. Next one is disaster recovery. This is one of the factors that contribute to the success of business in controlling the resources. Like no matter how in control an organization may be, when it comes to its own processes, there will be always few things that are completely out of our control. And the download time in the service leads to loss in productivity, revenue, organization reputation, etc. So, in order to help to speed up the recovery, we have cloud service providers where the data recovery can be done very quickly for all kinds of scenarios, from natural disasters to power outrages. Next one is fault tolerance. The Fault tolerance itself refers to like network, database, storage, and server array or cluster anything. Okay, that is designed to avoid loss of service by reducing or managing failures to the equipment and minimizing the planned downtime. So, in an organization, all these are expected to be highly available. No location constraint, which means for cloud computing, we have the ability to access data from home, from office, or any other location, but provided we have an internet connection. So if we need access to our data while we are on offsite, it can we can connect it through virtual office or quickly and easily. Next comes the deployment models in cloud. There are three types of cloud deployment model, and here we'll see each deployment model which is defined where the infrastructure the for the environment is located. The cloud deployment models consist of public cloud, hybrid cloud, and private cloud. First, we'll see about public cloud. So this consists of different variety of clients that store the hosted applications and files, data, and other resources on a virtual server. These services are available for general public and are shared among multiple clients through a service provider. Public cloud services are free or offered on a pay-per-use pricing model. Say, generally, service providers like AWS, Microsoft, and Google own and operate the infrastructure and offer access only via the internet. Then second model is the private cloud. This is a computing model which offers proprietary environment dedicated to a single business or an organization. Like public cloud was available to all, but this is exclusively for the organizations alone. Like as with other types of cloud computing environments, private cloud provides extended virtualized computing resources through physical components stored on premises or at the vendor's data center physically. This public will be accessed, but this private cloud will be provided exclusively for an organization. For example, you can consider HP data centers, Microsoft, and Ubuntu and all. The third deployment model is hybrid cloud. This is exactly what name indicates, like it's a combination of two or more cloud solutions so that subscriber can subscribe to whichever variety he requires, like ranging from private cloud or public cloud. So the binary or the primary benefit of this hybrid cloud is the functionality of service which is available to the clouds, sorry, to the clients. Like the services like multiple types of deployment models, the hybrid cloud is growing in demand and popularity. Like as more businesses has adopted cloud solutions and primary part of business model with technology. Next, we'll see the principles of cloud computing. So there are five essential characteristics or five principles for cloud computing. Sorry, not five, it is six principles to scale up cloud computing. The first one is federation. Here in this, the customer's cloud resources are available unlimited, but every cloud has a finite capacity. If the customer demand grows, then continuously, then the cloud has to grow beyond its capacity. For that, the service provider forms federations to enable collaboration and sharing of resources. So this Federated cloud must also allow the virtual applications to be deployed across federated sites. This virtual application should not be location dependent and it should be able to easily migrate between the sites. Okay, so the federated members must be independent as to ease the competitive service providers to federate. The next one is mm, independency or freedom. The cloud computing services must offer like full independence to the end users, so which will allow the user to use the cloud service without relying on any specific cloud provider. So even if the cloud provider must be able to manage and control the computing services without sharing internal details with the customer or the partner. The third principle is isolation. Isolation, like we are all aware of the fact that a service provider offers his computing resources to multiple end users. So end user must be assured before he is moving his computing cloud computing, that is data or information would be isolated in the cloud and it cannot be accessed by the other members sharing the cloud. Then the next one is elasticity. This refers to the resources that should be elastic. That means the user must be free to engage and release the computing resources on its demand. The next one is business orientation. So in business orientation, before like moving to the mission critical application of cloud, the companies must ensure the quality of service offered by the cloud provider. Here, the cloud service provider must also develop a mechanism to understand the exact business requirement of the customer and customize the service parameter according to the customer requirement. The last principle that scales up to cloud computing is trust. So trust is more important factor that any customer makes any customers to move their computing over the cloud. So for the success of cloud, trust must be maintained. The cloud customer and cloud vendor are also among the different cloud providers to form the federation. So these are the six principles that make that scale up to the cloud computing. So next we'll see about the NIST cloud reference architecture, which identifies the major actors, their activities and functions in cloud computing. So according to the diagram, this diagram is a generic high-level architecture and it is intended to facilitate the understanding of the requirements, users, characteristics and standards of cloud computing. So first in this NIST architecture, we'll see the actors. Who are all the actors? Like the first actor is the actor is nothing but an entity which may be a person or an organization that participate in transaction or process or performs a task in cloud computing. The first one is cloud consumer. It can be referred as a person or an organization that maintains a business relationship with the user service form cloud provider. Okay, and the next one is cloud provider. This is referred as a person or an organization or entity responsible for making a service available to interested parties. The third one is cloud auditor. It's a party that can conduct independent assessment of cloud service information system, operations, performance, and security of the cloud implementation. Next one is cloud broker, which is an entity that manages the use, performance, and delivery of cloud services and negotiates relationship between cloud provider and cloud customer. The last one is cloud carrier. This is considered as an intermediary that provides connectivity and transport of cloud services from cloud providers to cloud consumers. So now let's see the scenarios on which this cloud actors work on. So to start with, the first one is a scenario for cloud broker. Here, a cloud consumer may request service from a cloud broker instead of contacting a cloud provider directly. So here, the cloud broker may create a new service by combining multiple services or by enhancing an existing service. So according to this example, the actual cloud provider is invisible to the cloud consumer, and the cloud consumer interacts directly with the cloud broker. Then next one is a scenario for cloud broker. Sorry, for a cloud carrier. So second one, the in the slide, you can see the second scenario, which is for cloud carrier. Here, this cloud carriers provide the connectivity and transport of cloud service from cloud provider to cloud consumer. Like you can see from the figure, a cloud provider participates in and arranges for two unique service level agreements, like one with the cloud carrier and the one another with the cloud consumer. A cloud provider arranges service level agreements with the cloud carrier and may request dedicated and encrypted connection to ensure the cloud service with the cloud consumer. The last scenario is a scenario used by cloud carriers. For this, a cloud service or a cloud auditor conducts independent assessment of the operations and security of the cloud service implementation. Here, the audit may involve interaction with both cloud consumer and the cloud provider. This is all for the video regarding deployment and architecture model of cloud. Thank you.